Welcome to Chapter 10.6.3, where we will finish covering how to create a fully integrated user interface for all the systems in our building. Climate control and lighting. There will be a subsequent chapter in which we'll explore some interesting tricks to develop even more powerful interfaces than the one we're wrapping up today. Let's continue where we left off in the previous chapter. These two new variables have already been exported and are positioned at addresses 340 and 341. So, how are we going to make our buttons work? We'll connect them to our Adquio Pro at memory position 340, and we'll specify that this button should be active when the variable contains a value of 1. What happens is that this variable will hold values ranging from 1 to 6 because it will indicate whether button 1, 2, 3, 4, 5, or 6 is active. Therefore, the off state won't be useful as it will never be 0. To address this, we have an option below that allows us to specify that the button will be deactivated as long as it does not contain the value for on. We'll select this option, which means that this button will be deactivated if it contains a value of 2, 3, 4, 5, or 6, perfect for our current requirements. Now, what are we going to do with the remaining buttons? We'll set the second button to a value of 2, keeping the exact same configuration. Then the next one to 3 and so on until we reach 6. I'll go ahead and configure these, and once I'm done, we'll continue. Each button has been set up. You may recall that the first one was set to 1. Now this one is set to 2, as we mentioned a moment ago, and this one is set to 6. So, if we test it, we'll see that pressing any of these buttons results in mutually exclusive functionality, which is exactly what we need. Let's select the reception area and observe that the lower buttons will work uniquely. It's true that we created a variable in Adquio a moment ago to store the status of these buttons, but we actually don't need it. We'll only need the zone variable, as these buttons will work in a special way, ensuring that there is always a selected zone in the upper area, as it's impossible for none to be active. When we press any of the buttons, the previously selected one deactivates, but it never allows all the buttons to be deselected. Since we always have a selected zone, we can now make these buttons link to a specific control window for ventilation. Depending on the selected zone, we can control ventilation, the temperature of that zone, and so on. Let's see how we do this. For example, if we have developers selected and we press the fan button, it takes us to a window where we can control the fan speed. We have a control that allows us to turn it off, set it to the minimum, medium, or maximum speed, and an additional button to go back to the main menu. The same applies to temperature. We can easily increase or decrease it, and there is a button to return. The lighting intensity can vary from off to 100%, with the added ability to fine-tune it using a value displayed at the bottom. We also display the RGB color. In this case, it's set to white, but we could choose, for example, warm yellow. We have a monitor that indicates which color we have selected. Let's leave it approximately at white. Finally, we have the color temperature. In this case, it's almost at the coolest color, but we can adjust it to the warmest color, reaching up to 6,500 Kelvin, and then return to the main menu. How did we create all this? We simply created 5 new screens, 5 new windows like this one, where we added a background. Let's look at them. Take the fan window, for example. We'll switch to design mode. This window has a background we designed in Canva, with labels for the potentiometer and all the other elements placed here. The fan icon, which we created earlier, as you may recall from the first chapter of this series, and a return button, which is a system button that sends us back to panel 1. One very special label is a variable label. For this, we used the virtual multiple text component, connected to the same variable as the zone buttons, position 340. This component is capable of displaying different text based on the value of a variable. Therefore, we configured it so that for value 1 it displays reception, for value 2, corridors, for value 3, developers, and so on, up to value 6. Each of these elements can be configured to correspond to a specific value. Additionally, the condition in this case is that we want it to match values 1, 2, 3, 4, 5, and 6. We can select the text we want to display, the font size, type, bold, italic, underlined, etc., or standard. In this case, we've set it to bold, as it's the window title. We can also choose the color of this font and so on. We created 6 of these, all with the same characteristics, except for the variable value that displays the text and the text itself. This way, we ensure that when something is selected on the main screen, these labels change to the correct value based on the pressed button. The rest is just an image. We simply selected the fan that we previously designed. This is fixed text, with the content written here, and we just selected a size that looks appropriate based on our needs, a little smaller than the top title. Lastly, we have the return button we've already seen. It's important that the ventilation control in this case is designed according to the specifications of the HVAC system we're connected to. This HVAC unit can stop the fan or set it to the minimum, medium, or maximum speed, which would be at 100% of the fan's speed. There are other cases where fans are proportional, allowing for a percentage setting between 0 and 100. For instance, in this case, it's not like that. This machine has these 4 options, ranging from off to maximum fan speed. Therefore, we designed the window according to these needs. Alright, as we can see, all the other elements are similar, but adapted to the specific controls they manage. In this case, for example, the RGB controller is created with an RGB LED controller component, set as an RGB controller. The same control we have below can also be selected to be just a display without modification capabilities. In this case, it's the same control, connected to the same RGB variables. These variables need to be 3 instead of 1, as we're controlling the components of the color. These components come directly from the color variables of that scene, group, or luminaire. Therefore, we can send them directly, and that's it. The rest of the window is identical to what we've seen in previous cases. This special label that varies based on the selected zone, an image, fixed text, and a button to return to the main menu. All these windows are identical. They just have different controls based on what they host. Thus, within Adquio, the only thing we need to consider is that when the fan button is pressed and modified, it should save the position where the potentiometer is left for the selected zone, according to the pressed button. We know that there will always be one pressed, so no errors are possible. Let's see how to achieve this in Adquio, so that when we select the reception fan, it does one thing, and when we select the corridor's fan, for example, it does something else. As you can see, we're already inside our memory device. Within this device, we have the zone that we've already seen previously, and we have here a slider position, which is the position of the potentiometer for the fan speed. We can see that we have a script that, when this position changes based on the selected zone, will write to different HVAC units. Let's see what HVAC units we have. Unit 01 for engineers, Unit 02 for administration, Unit 03 for the development department entrance, Unit 04 also for the development department, Unit 05 for the main conference room, etc. So, depending on which buttons are pressed in the upper section, we'll make this potentiometer act on the correct zone based on the selected zone. For this, we have a script here, and we're going to look at it closely. Firstly, we have an event that captures when the variable in the memory device changes. What changes is the slider position. What it's going to do is read the zone we're in from the memory device, which, as you know, is powered by the 6 buttons we have on the interface. We'll use a case statement. When the button is 1, we'll write to HVAC unit 07, specifically to the set fan variable, which allows us to set the fan speed. What are we going to write? We're going to write the contents of the variable EV dot new value, which we get from our event. EV means event value, and new value is the content of the variable, indicating the position where we've left the potentiometer. We're passing it directly to this variable of the machine. Next, if the first condition is met, that the value is 1 for button 1, then we execute a break, as there's no need to check further conditions. If the variable is 1, it's impossible for it to have any other values. Now let's look at a special case for button 3, which represented the developers department. This department has 2 different climate control units because it's a large area. Therefore, we need to simultaneously write the same value to both Unit 3 and Unit 4. We can see that simply by moving the potentiometer and based on the button pressed, the command will be sent to the appropriate unit. Another feature we'd like to implement is to ensure that whenever we return to this window, the potentiometer is set at the same position we left it in. This means that if it was set to the minimum for reception, we don't want it to appear at the maximum when we re-enter. We want it to remain where we left it. To achieve this, we need to ensure that whenever these buttons change, the components are loaded with the necessary variables for each of these possible options. In this case, we're only dealing with the fan. Let's make sure this happens. So, when the zone changes, we need to ensure it matches the same position it was left in on the machine. It should retrieve the value of the potentiometer and apply it, ensuring that when the user enters, the correct value is already displayed. To do this, we need to delete this code. We'll do exactly the same thing, but in this case, it's the zone that changes. Therefore, the variable, IRV, will receive the zone we have switched to. We can copy something similar to what we have here. Let's copy it here. The only difference is that we won't use zone, as it is not defined in this function. Instead, we'll use ev new value. Okay? And what are we going to do? We're going to write to the memory device under slider pos. There's a third parameter we need to define here, which is the value we want to write into the memory device and into the slider pos variable. And where do we obtain this value from? Well, it will be read from the correct machine, which we already have set up here. So let's input devices and paste it here. We want to read from machine UE07, and we want to read it now. Let's see which is the correct variable to read from. Before we move on, let's tidy up the unnecessary parts here to keep it clean. Let's save it and check within the devices. In this specific case, we were working with reception under UE07, which variable provides us with the fan speed. We can see we have set fan, which is what we configured when moving the potentiometer, and below it, we have another variable, read fan, which is the read-only variable that will tell us the current fan speed. So let's go back to our script and input that variable name here. For now, we won't do anything with the others, but let's assume we have to do exactly the same as above, but in reverse, writing to the slider the position of that particular machine. I'm going to do this, and once it's finished, we'll return. I've now completed it. there's just one detail to mention. Remember that in the previous case, when we were setting the fan speed, specifically for the developers department, since they have two climate control units, we were writing to units 3 and 4, right? In the event that button 3 is pressed, as we know we are always writing the same value to both units, when it comes to obtaining the value for the potentiometer, we'll take it from unit 3. There's no need to take it from 2 units. In this particular case, we'll take it from the first one, and that's all. With this, we ensure that the machine's value is correctly set when we enter the potentiometer window, exactly as we left it. Similarly, we'd need to do the same for all the others. With all this, we will achieve exactly the same result. If we change the temperature will be loaded again for this department when we enter the window, and the same applies to all the others. Right. With this, we've completely finalized the functionalities of this control screen. In this particular case, we've been working with our new Adquio Wall Screen control interface with an 8-inch display. Therefore, the buttons are large and very easy to use. There will be one more chapter in this series on creating a real interface using Adquio tools, which will be dedicated to important tips and tricks for overcoming small limitations in this interface development system. See you in the next chapter. Goodbye.